Okay. All right. We're looking at the topic laboratory equipment. Laboratory equipment. Okay. So what are laboratory equipment? What are laboratory equipment? What are laboratory equipment or laboratory apparatus? So before we come to know the laboratory apparatus, we're going to look at what is a laboratory. What is a laboratory? Now let us begin. A laboratory is a room or building equipped with scientific experimentation or research. It's a room or building equipped for scientific experimentation or research. It simply means that the equipment that are found in the laboratory are meant for scientific experiment, scientific research, scientific discovery. So it is not a place to go and play, it's not a place to go and joke around, it's not a kitchen. All right, every tool that is being found in the laboratory is to carry out scientific experiment and scientific research. Okay, remember in our previous class we looked at the method of scientific observation method of scientific discovery. We talk of observation, we talk of pattern, we talk of research, we talk of hypothesis, we talk of theories, we spoke of laws, right? I didn't mention them in any order, but we looked at these method of scientific discoveries. Okay, so today we are speaking here that the laboratory tool equipment are meant to carry out research, okay, which relate to science. Now let's carry on. It is a special facility. It is a special facility where experiments are done and typically contains scientific equipment and apparatus. So it means that the only equipment that can be found there are equipment that are meant for scientific experimentation and research. So they usually contain scientific apparatus. Okay, let's carry on. Now, what then are laboratory apparatus? So we now know laboratory. So let's define those equipment that are found in the laboratory. Are you with me? All right, let's carry on. Okay, laboratory apparatus refers to the various tools or equipment used by scientists in the laboratory. So the apparatus here are the various tools, are the various equipment used by the scientists. Okay, used by the scientists that are working in the laboratory. Are you getting me? So the tools are those things that scientists use to carry out the research and experimentation. Now, some common laboratory apparatus include test tube, beaker, conical flask, flat bottom flask, round bottom flask, funnel can be plastic or glass, fizzle funnel, brush, Goof's bottle, triple stand, retort stand, spatula, Bunsen burner, separating funnel, wire glass clamp, beehive shelf, gas jar, desiccated, reflux condenser, Leibig condenser, pipette, we have burette, we have delivery tube, we have the flagrating spoon, we have U-tube, we have thermometer, we have aspirator bottle, we have wash bottle, we have chemical balance, we have reagent balance, reagent bottle, we have foam cupboard. So these are some of the lab or laboratory apparatus. Follow. We'll move further. So if you go to some certain secondary school, you will definitely see some of these apparatus live and direct. All right. So let us carry on. Let's look at one and what each apparatus. Let us explain them one after the other. Okay. All right. Let's carry on. Let us look at them one after the other. Let us look at them one after the other. We have number one. We have evaporating dish. Evaporating dish, you can see from the screen there, from the picture displayed there, you can see there on the screen, you can see there, you can see the evaporating dish is there. You have evaporating dish is there, evaporating dish. Okay, evaporating dish. All right, so okay, now let us explain each of them one after the other. Let's explain one after the other. So number one, we have evaporating dish. You can look at the picture sent there. You can see it here on the screen. Here, evaporating dish. It is here. Evaporating dish there in the middle. Evaporating dish, and we say evaporating dish is made up of porcelain. It's made up of porcelain. It may be round or flat bottomed. It is used in evaporation of solution to dryness. So if you want to carry out evaporation in the lab, maybe to evaporate solution, maybe you want to evaporate the salt water solution, you want to evaporate the water so you can have just salt alone, then you can use what evaporating dish, which we say it can be round bottom or it can be flat bottom. Okay, so evaporating dish is basically used for what evaporating solution to dryness. So when you want to evaporate any solution, you use evaporating dish. That's number one. Then number two, we have beaker. We have beaker. Number two, beaker. It is available in different sizes. It is flat bottom cylindrical. That means it has a flat bottom and it is like a cylinder. It is cylindrical, graduated, and usually with a lip for easy pouring of solution. It is used to hold solution or measure solution during an experiment. So you can look at the screen very well there. You can just spot it out. Let me get it here. You can here the screen. So you can spot it out. You can see there a beaker. It has like measurement. So it is being used to carry out measuring, to measure solution in the laboratory. All right. So the next one is aspirator bottle. Aspirator bottle. Aspirator bottle. Aspirator bottle. It is a jerry can made up of plastic or glass with a screw tap. It is a jerry can made up of plastic or glass with a screw tap. It is used for storing distilled water during an experiment. So the aspirator is used for storing distilled water during an experiment. Okay, there's a kind of water called distilled water that is meant to carry out certain experiment. So it is being stored in a aspirator bottle. Okay, then next one we have here. Okay, aspirator bottle should be there. Let me check the screen. Aspirator bottle. Okay, it seems not to be one of the It seems not to be one of the equipment listed here from this picture I got. Okay, problem. Let's move further. Aspirator bottle. Okay, the next one is crucible. The crucible. So a crucible is usually made up of porcelain. It's made up of porcelain with a lid to match. It said it can withstand high temperature, hence it is used for ignition of substances until they are decomposed. All right, so a crucible is used to ignite substances until those substances are decomposed. All right, a crucible, and from the screen it is there from that picture sent. A crucible. Where is it? Crucible. I think I saw it here. I thought I saw it here. Okay, if it's not, I think it should be there. Okay, let's move to the next one. Okay, so that's crucible we have discussed. The next one is Goof's bottle. Is a Goof's bottle. A Goof's bottle is a glass bottle used during the preparation of dry gases to hold liquid or solution that are employed as drying agent or in absorbing unwanted gases. So we are looking at a Goof bottle. It's a bottle used during the preparation of dry gases to hold liquid. Okay, to hold liquid or solution that are employed as drying agent or in absorbing unwanted gases. So that's the Goof bottle. Goof's bottle. Next, what we have here is conical flask. A conical flask, it is commonly used during titration experiment. It is usually graduated and used to estimate the volume of a solution. So a conical flask is used to measure or estimate the volume of a solution. Next one is flat and round bottom flasks. Now, these are made of glass and are mainly used for boiling, especially during distillation experiment. So we are carrying out distillation, which usually is used to separate to separate petrol. Petrol is obtained from crude oil, right? So crude oil contains is a compound that contains a lot of other elements inside crude oil. So they carry out the process called fractional distillation to remove fuel, to separate fuel, gas, kerosene, aviation fuel, grease, engine oil, and so on and so forth. All these compounds that are found in crude oil. Through the process of fractional distillation, we can separate them and they become different independent substances. All right. So here we are saying that the flat and round bottom flask is used for what? Boiling, especially during distillation experiment. So we are carrying out a process of separating distillation, one of the separation technique which we are going to learn. So when you are carrying out distillation, which is a separation technique, you use the flat and round bottom flask to boil the solution. Okay, all right. Next one. Let's move to the next. Next one is standard volumetric flask. So a standard volumetric flask is a flat bottom, pear-shaped and with a narrow neck. It is used in preparing standard solution to a specific or definite volume. So the standard volumetric flask has what is it? I will take it again. It has a flat bottom, pear-shaped, and with a narrow neck. It is used in preparing standard solution to a specific or definite volume. So we are saying that the standard volumetric flask is what is simply used for what? Preparing standard solution to a specific or definite volume. That means you want to get, let's say, the volume of the amount of gases you want to have to carry your experiment is 3.3 millimeter cube, right? Sorry, milligram cube, 3.3 milligram cube. When you use this volumetric flask and measure it, you can get the exact amount, exact volume of gas that you want to use for your experiment. The next equipment here is the fume cupboard. The fume cupboard. A fume cupboard, it is usually a wooden cupboard with its front made up of glass, which can easily move up and down. It is used to prepare poisonous gases. So you are carrying out gases that has to do with that are poisonous. You use a fume cupboard to prepare them. All right. The next one here is distillation flask. Distillation flask. Let's follow your understanding. Distillation flask, and we say distillation flask, and we say a distillation flask. It says it has a flat or round bottom with a slanting long side arm. It has a flat or round bottom with a slanting long side arm. It is used during distillation. Distillation, as the name implied, distillation flask is used during distillation. Okay, let's carry on. The next one here is bell jar. Bell jar. That is the next lab apparatus. Bell jar. I said it is made up of thick glass, cylindrical, tall, and usually with a knob at the top. It is used in combustion experiment. So we are carrying out combustion experiment. Yeah, the bell jar play a role in the experiment. I will take it again. A bell jar is made up of thick glass, cylindrical, tall, and usually with a knob at the top. It is used in combustion experiment. Hope you're following. Please follow carefully. All right. Next one, number 12, where we have is gas jar. Gas jar. So we say a gas jar, it is made up of thick glass, cylindrical, tall, and sealed at the bottom. It is used for the collection of gas over water or dry gas. So a gas jar, it's made up of thick glass, cylindrical, tall, and sealed at the bottom. It is used for the collection of gases. So a glass jar is meant to be used to collect what? Gases. Okay? It has the same ability like a gas cylinder that has the ability to hold gas. Okay? To hold gas for a particular period of time. Do you understand? Okay. So that's glass jar. The next one, number 13, which we have there, is dropping bottle or dropping pipette. Dropping bottle or dropping pipette. All right. It is used, a dropping bottle or dropping pipette is used in keeping or transferring solution or reagent that are required in drops during experiment. So there are certain solutions that you require to drop them little tip, like a tip of it. You know that experiments are very delicate. People are preparing experiment. You don't just prepare it anyhow. There is a particular amount of a solution that is required for every experiment. If you put more or put less, you may have problems. Do you understand? If you put more or you put less, you may have problem. Hence, it is paramount that every solution must be measured accurately. Okay, so when you're looking at this, a drop bottle is used to just drop a little, okay, a little of it, a little amount, maybe one drop. All right, something that may be difficult for you to do if you don't have it. So with a drop bottle, you can easily put the exact volume of gas or solution that is needed to carry out the experiment. Then the next one, number 14, is spatula. 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 Okay. A spatula, it is made up of iron which look like a spoon. A spatula, the spoon-like equipment, it is used in transferring little quantity of solid into test tubes. It is used in transferring little quantity of solid into test tubes. All right, so that is that. Next one is burette. A burette is used during titration experiment and also in transferring small volume of solution. A burette is used during titration experiment and also in transferring small volume of solution. So you want to transfer little volume of solution from one place to another, you use what? A burette. Number 16, we have retort stand with clamp. Retort stand with clamp, it says it is used as support during experiment. All right, it is used as support during experiment to hold the other apparatus. Then number 17, we have desiccator. Desiccator is used in keeping and drying solids in an atmosphere that is dry and free of dust. Desiccator is used in keeping and drying solids in an atmosphere that is dry and free of dust. And the next one, number 18 here, is measuring cylinder. Measuring cylinder is used to measure the volume of solution. It's used to measure the volume of solutions. Number 19 is Kip's apparatus. Kip's apparatus this is used in the intermittent supply of gases. It's used in intermittent supply of gases. Then number 20 is wire guards. Wire guards is used as a support for flask during heating. A wire guard is used as a support for flasks during heating. Okay. Then the next one is filter funnel. Filter funnel, it is used in filling the burette or in supporting the filter paper during experiment, during filtration. A filter funnel is used in filling the burette or in supporting the filter paper during filtration, when you're carrying out filtration. Okay, the next one, number 22, about 25, we're almost there. Number 22 is condenser, or it's called Liebig. Condenser, it is used in cooling or condensing vapor into liquid during distillation or when refluxing. So a condenser is used to cool or condense vapor. You know what is vapor? If for instance, you're cooking and you're cooking now, your pot, you're cooking, let's say you're cooking yam, for example, or rice. When you notice that when you go and open the pot, you see smoke like vapor going up. It looks like smoke. It's not smoke, it's called vapor. And that is what we call that water vapor. Do you understand? And when you open the pot, you notice that some drops of water will be dropping from the cover of the pot. That drop of water is not the water inside the pot. It is the water that became gas, became vapor, that tried to evaporate, that couldn't, that was trapped by the cover. It later condensed into liquid. Do you understand? Like, what I'm saying is that it evaporated as vapor. It tried to evaporate from the pot as vapor, but it got trapped. There was no space for it to go. It got trapped in the cover, and later on becomes what? It becomes condensed into liquid again. All right, so that's what we're saying there. All right, let's carry on. The next one here is centrifuge. Centrifuge. A centrifuge is used in separating fine solid particle in a liquid. So there are certain liquids that contain solid particle. So if you want to separate them, you use a centrifuge to separate solid from what? Liquid. All right. Next is test tube. Test tube. Test tube. A test tube is used in qualitative analysis to hold reactants. A test tube is used in qualitative analysis to hold reactant. Finally, we have separating funnel. Separating funnel is used in the separation of immiscible liquids. It's used for the separation of immiscible liquids. Immiscible what? Liquid. Now, what are immiscible liquids? Hold on, let me get it. What are immiscible liquids? What are immiscible liquids? What are immiscible liquids? So, immiscible liquid are simply liquids that cannot be mixed. They are liquid that when mixed they cannot blend. Okay, when you mix immiscible liquid together, they will never blend. For instance, you cannot, unlike if you carry, let's say you carry let me use tea. Okay, you use tea and milk, you put it together and you mix, they can blend, it can go, right? But if you try to mix something like water and oil, no, it won't work. Oil will go ahead above the water. All right, it will show that there's oil in. Now you cannot mix it and it will blend. For another thing that you cannot mix, that immiscible liquid, are gasoline, like fuel, your generator fuel, gasoline and water as well. It can't go, as well as mercury and water. These liquids cannot be mixed very perfectly. Even if you mix them, they will not blend. They won't blend. Do you understand? All right, next let's look at laboratory safety rules. Laboratory safety rules. A lab, just as some special locations, is a place that contains both good and dangerous substances. So there are substances in the laboratory that are dangerous. For instance, acid is very dangerous. Sharp objects such as scissors, razor blades, and certain chemicals are not good. Chemicals like tetraoxosulfate acid, other chemicals, like hydrocarbons and so on and so forth, that are most of them that are found in the lab are not good, are not safe. All right, there are some chemicals that are very highly corrosive, chemical like nitric acid, and most of these elements, most of these solutions, that are not good. Okay, hence it is very paramount that we spell out certain rules, safety rules that must be observed in order to successfully operate in the lab and come out safe. Do you understand? It is not good that you enter the lab and you come out burnt, because if you play with acid, you will get burnt. Okay, if you play a sharp object, you may get injured. Hence, let's look at the safety rules that are found in the laboratory. Number one, laboratory safety rules. Number one, dress well for the laboratory. Dress well. There are specified clothes, like let's say what you call lab coat. So they say dress well for the laboratory. Wear a lab coat, safety goggles for your eyes, footwear, and tie long hair back to avoid catching fire. Do you hear the rule? These things are real. Okay, so when you enter the lab, where there are acid that can explode. Okay, there are solutions that can when it comes in contact with your hair or come in contact with some area part of your body, you may get burnt. So they are saying here that you should wear your lab coat. Number one, you should wear safety goggles for your eyes, which they wear. And I will show you a picture of it I will show you a picture of how you should dress in the lab. Just hold on, let's carry on. Then there is footwear, and there is tie long hair backward to avoid catching fire. Number two is keep pathways clear by placing items such as books and bags on the shelves or under the table works. Books like it is can actually, catch fire. Okay? Yes, because of how light the papers are. So they are saying while working in the lab, you shouldn't place book side by side with your experiment, except you need it when you want to read. But the book should be kept far from solution that can cause what fire. The next one is number three, do not taste or smell chemical. You don't try and say, let me see. There's a chemical that look very attractive. You see some of them, you think that it's Fanta. You see some, you think that it's juice. You not say, okay, let me test and see whether it's sweet or bitter. No, you don't test chemicals. You don't smell them. Okay, they are not that. They may be very dangerous to your health if you smell them. So you don't taste chemical. You don't smell chemicals. Number four, unauthorized experiment or procedures must not be attempted. Don't try to carry out any unauthorized experiment. No, it's not allowed, please. Ensure you carry out that which is specified, that which has been tested and trusted to be safe to experiment. Carry it out. Don't carry out experiment that may cause damage, may cause fire, outbreak in the lab. Do you understand? So don't only follow the right procedures. Don't try to bypass procedures. I told you in the beginning that if you use too much chemicals, it may be detrimental. If you use too less chemical, you may not get your desired result. So you must follow as it is specified by those who have done the experiment and have trusted it and brought out the procedure that should be followed. So follow it carefully to arrive at your desired result. Number 5, pay close attention to any caution described in the laboratory exercise. Pay close attention to any caution, to any warning. There are some chemicals they will write warning. Don't touch with your bare hands. Warning. Only an expert should hold it. Warning. To keep out of reach of children. Warning. Don't take it outside. There are rules and regulations that are specified on each of the chemicals. So follow them carefully and pay keen attention in order not to make mistakes. Number 6, do not leave your assigned laboratory station without the permission of the teacher or the scientist that is taking, or your teacher or your mentor. Okay, do not leave. If you say stay on table 1, remain on table 1 until you say leave table 1, come to table 2 before you can now leave. Okay, if you say stay on table 3, stay on table 3. Don't move until it says move. Do you understand? Then the next one, number 7, do not lean, hang over, or sit on the laboratory tables. No. Those tables may not be strong enough to carry the weight of a human being. So don't sit on them. Don't lean on them. They are meant for only experiments. Okay? That is that. Number 8, fooling around or horseplay in the laboratory is absolutely prohibited. Laboratory is not a playground. One thing with human beings is that we like to do the wrong thing at the right time. So we'll go to the laboratory, you're playing. No, you don't play in the laboratory. You don't joke around. You don't throw stones. You don't just run around. When you enter there, you know what trick with there. You focus on that which trick with there, and you ensure you do it perfectly and carefully. Don't go in there and be running around. Don't go in there and be playing around. Stay well, stay safe, and stay cautious to every rule given to you. Do you understand? And final number 9, no finally, number 9, learn location of the fire extinguisher, eye wash station, first aid kit, and safety shower. We don't wish and we don't prepare laboratories, or we don't take children to the laboratory for them to get hot. But just in case, accident, there's what you call accident are inevitable. So if accident, which are inevitable, happens, then ensure that you know where fire extinguisher is, just in case there's a fire outbreak. Your knowledge of fire extinguisher can save life. You know where it is, you know how to use it. So in case of any fire, you know what to go and use to quench. Do you understand that not every fire you can use ordinary water to quench? There are fire you don't use ordinary water. So when you see fire outbreak, just quietly run to where fire extinguisher is and take hold of it. Don't carry any acid to throw into the fire to stop it. Don't use anything that's not specified to throw into the fire to stop it. Go and get a fire extinguisher. Also, just in case solution enters your eye, you should know where to wash your hand. Your safety shower, where you can run in and quickly wash off the chemical. Because as the chemical like they touch your body, you don't wash them off immediately, you may get what? Burnt. Do you understand? All right. Next one, number 10. Number 10. Report. Number 10. Report all accidents, injuries, and breakage of glass or equipment to instructor only. If there's any accident, there's any injury, don't try to say, let me treat myself. No. If you get affected with, maybe you get burned with by an acid, go to your instructor to tell him or her, as this is what has happened. He or she will now take you through and show you and tell you what you need to do, and give you what is required to be able to reduce or advance the effect of the solution on your body. The next one is always the last one. Number, I think this will be the last one. Sorry, not the last one. Number 11. Always follow the instruction given by your teacher. Don't give your own instruction. Follow what I've been told. Follow everything that you have been told to do. Number 12. No eating or drinking in the laboratory at any time. You're in the laboratory. Chemicals. So you don't go and handle chemicals, come and handle food. No. You ensure that you are in the laboratory, do what you there. You want to eat, leave the laboratory, go to the kitchen and eat. Go to the cafeteria or wherever the eating spot, that you eat, you go and stay. You don't stay in the lab to eat. Lab is not the kitchen. Lab is not the dining table. Okay? So take note. The last one, number 13, last but not least, leave your workstation clean and in good order before leaving the laboratory. Ensure that every equipment you carry, return it back to where you carried it from. The reason being that when you go back next time, you can easily find them. And also, you avoid them getting destroyed. If you leave them on the table and once the table falls and break, it may break some lab apparatus. So return everything back to where you kept them and ensure your lab is well cleaned and placed in order before you leave your laboratory. Do you understand me? So these are the basic laboratory rules and regulations. All right, over here we have some questions, some objective questions. So let's try to answer them. Some objective questions. Let us try to answer them. Okay. Number 1. An apparatus in the laboratory in which the preparation of poisonous gases is done is called dash. So the apparatus that is used to carry out preparation of poisonous gases is called what? A. Distillation tank. B. Aspirator. C. Fume cupboard. D. Bell jar. So what do you think the answer is before I tell you mine? Hold your answer to yourself and see. If the answer match with mine, let's see, we know that you understand. So what is your answer? The apparatus in the laboratory in which the preparation of poisonous gases is done is called what? A. Distillation tank. B. Aspirator bottle. C. Fume cupboard. D. Bell jar. What is your own answer? Okay, I want to hear the answer now. Let's go to, I will read out the question, then I will tell you the answer later on. So, what is your own answer? Write it down. If it's A, put A. Move to question 2. Then when you are finished, when you go to question 5, I'll come back and tell you the answer. Then you mark yourself, whether you're right or you're wrong. You mark yourself and know what you scored. Okay? Ensure you mark yourself. Let's know what you scored. Alright? Question 1, again, I'll take it again. An apparatus in the laboratory in which the preparation of poisonous gas is done is called dash. A. Distillation tank. B. Aspirator bottle. C. Fume cupboard. D. Bell jar. Write down your answer. When we are done, I will tell you the answer. Number 2. In the laboratory, dash is used for the collection of a gas over water. Collection of gas over water. A. Gas jar. B. Wolf bottle. C. Regent bottle. D. Burette. What's your answer? Put it down. In the laboratory, dash is used for the collection of a gas over water. A. Gas jar. B. Wolf's bottle. C. Regent bottle. D. Burette. Alright. Number 3. Two liquids which are immiscible, which with each other can be separated using dash. Two liquids which are immiscible with each other can be separated using dash. A. Bell jar. B. Gas jar. C. Wash bottle. D. Separating funnel. Ensure you don't look at the note. Don't look at the note. Just answer them based on what you know. A. Bell jar. B. Gas jar. C. Wash bottle. D. Separating funnel. Number 4. An apparatus used to hold drying agent during the preparation of dry gas is called dash. An apparatus used to hold drying agent during the preparation of dry gas is called dash. A. Conical flask. B. Gas jar. C. Wolf's bottle. D. Flat bottom flask. Number 5. A colored reagent bottle are used to store reagents which are capable of dash easily by sunlight. A. Evaporating. B. Decomposing. C. Dehydrating. D. Dissolving. So, what are your answers? What are your answers? If I tell you mine, what are your answers? Okay. Put down your answer and see what you will score. Okay, let me give you my own answers. Let me give you my own answer. Number 1. An apparatus in the laboratory in which the separation of poisonous gas is done is called C. Fume cupboard. Fume cupboard. Number 2. In the laboratory, dash is used for the collection of a gas over water. The answer is A. Gas jar. Number 3. Two liquids which are immiscible with each other can be separated using it can be separated using dash. The answer is D. Separating funnel. Number 4. An apparatus used to hold dry agent during the preparation of dry gases is C. Wolf's bottle. Number 5. Colored reagent bottles are used to store reagents which are capable of dash easily by sunlight. The answer is that number 5 that we are Color reagent bottles are used to store reagent which are capable of easily dashed by sunlight. So the answer is decomposing. So when reagent, which is a chemical solution, is being exposed to excessive sunlight, it will be decomposed. Okay, so the answer is decomposition. That means it will break, the chemicals will be separated. It will not be like single substance, homogeneous substance. It will fractionalize the solution into different particles, or into different solutions, to different substances. All right, so the my answers: number one, the answer is C; number two, the answer is A; number three, the answer is D; number four, the answer is C; and number five, the answer is B. So mark yourself and see what you scored. So that is for today. That is it for now. And I'm gonna give you an assignment, something to go and read on laboratory, revise on the 5 safety measures that can be taken. You can come up with other 5 safety measures that are you can come up with other 50 measures that can be employed in a laboratory, and also state the uses of the following laboratory apparatus: separating funnel, condenser. Just revise on it and it's prepared. So that is it from here. Thank you for joining from here. This the end of our class for today. So for this, we sign out for today. Stay well, stay blessed. Bye for now. So just don't forget, if there's any question, yes, any part you're confused, feel free. You can leave the question in the comment section, or you can reach out to me personally, and it will be responded to as soon as possible. So from the decks of College Virtual School, bye for now.